Hello, hello, hello. I'm ready to tackle Quest 15 of Everybody Codes. Finally caught up from my busy week. Yeah, got my code here ready to run. Let me refresh on this. There we go. Chest is ready to go. I'm ready to go. So, let's go. Okay, we got ourselves a maze. Some more pathfinding. Big fan steps. The total distance is 13 and 13, 26. Okay, is this a multi-pathfind? Okay, so each type of herb, you must step on the field where it grows. Represents race begins from this point. Top edge. First task to find the H. Huh. Okay, yeah, so it's Dijkstra's. Jeez, it's another pathfinding. I can see this one getting a little complicated though. Let me grab my Dijkstra. Let me grab my. Sure, we'll just grab actual Dijkstra. So let's first parse our world. Const world equals notes split on the new line that map each line into an array of characters. And let's determine our start. Let's say let's start as null for let c equals 0, c less than world 0 dot length, c plus plus. If world 0 c equals a dot, congratulations, I just found start. R0 C, and then C is what? C is whatever I just found it as. Great, so I find my start and then I stop. Okay. And then I'm just gonna go through this, build out the graph, Dijkstra's to all of the H's. Okay, so it's another one to find herbs for let r equals 0, r less than all the rows. And then all our columns. Don't forget 0 to handle our non-square universes. There we go. If world rc equals h, then congratulations, herbs.push. RC. So yeah, we're collecting herbs. We're also gonna make the graph. You know what? Let's do another iteration for that. Const graph equals new dictionary. Yeah, we're gonna do from and then a to. Const from key equals world. Well, no, it's r plus this plus c. If not from key in graph from key equals let's do this one because might need the actual weights. I'm not using a weighted one, so actually let's do this one. Okay, so we have that one. That's amazing because we'll need Dijkstra's to it and then Dijkstra's back from it, or I can see a chaining thing being here, which might be where I get stuck on part 3 for today. So we do that, and then it is for direction and directions. I think I have directions in a previous one. I do. There we go. For const ROCO of directions, const NR and C equals ROC plus CO. If world NR optional chaining, so it could be off the row. So if what you found comes to car, there we go, let's save that. If to car isn't truthy, so it's undefined, or to car equals a wall, then let's not look at it. Otherwise, let's look at it. So that will be graph from key dot push 2, well, it's 2 key. Const, well, I don't need a const, I'll just put it here. Plus NC. Okay, we now have our graph. We now need to, which one? The shortest one? Yeah, shortest one. So const distances equals Dijkstra graph the start, which is start plus R plus start C. Then we go through all the herbs and find the closest one. What closest equals number least steps to and least steps back, which for this instance I think it's just whatever you find, double it, right? So I think it's fine to just do number max safe. I have to look for smallest, so 4 const herb of herbs. If so I guess I need closest equals map min closest, and then will be distances to herb R plus herb C. Okay, I think that's it. Let's find out. Got to double it. Forgot to double it. Okay. Here comes the thing I didn't plan for. Not too different, honestly. Yeah, I mean, there's no moving things, so I expect this to work. And here comes the hard part. Lake. You cannot enter when one plant of each kind. 3 different types of herbs. A, B, C. 38. Okay. So it's a multi. So this is interesting. So obviously this is the next iteration of the multi-path algorithm. I haven't done a lot of these, to be honest. Haven't needed to. I imagine in part 3 you can wade through the water and it'll just, double your thing. But let's think through this. So 3 types of herbs, A, B, and C. So if I go to the shortest one to get A, and then from there, the shortest distance to find a B, and then from there, the shortest distance to find a C, I know that's not considering all of them and their locality and all that stuff. Let me see. So A on the left side, C in the left corner, first B from the left. So yeah, we go down, we get that one, and then go left or down, doesn't matter. Get the C, get the B, and then exit, right? Or do we need to exit? Alright. Okay, let me think of the naive way. So I just find the closest A. That would probably send me to this one, right? Then I find the closest C, or, well, I find the closest first one, which would send me to the A. Then if I'm there, I'd go to the closest whatever next one, which I think would be the C. Yeah, and then I'd go to whatever the closest next one is, which would be the B. So for each of these, I basically have a decision of like, okay, can I try all the other ones, or do I just stick with this one? So let me put it in here, because I can already see this brute not going too well. Get my example. They say 38. Let's put it in there. Yeah, have my start, I have my thing. Let's bring solve 2 into the equation. There we go. Let's get solve 2 in here. I'm going to look at the output, just so I can start to prepare myself. Boy, oh boy. Okay, so C, B, and A. I kind of just want to see how many there are each, but I can kind of see with my eyes. They got some cool patterns going on. Oh, and there's E's and there's D's and oh, jeez. Okay, So I think I'll do a naive approach and see if that suffices. So, solve quest 2 herbs, which will need to be a dictionary of herb type and then thing. So if it's greater than or equal to A and world RC less than to Z, const car equals, let's just, I'm going to use you a bunch. So it'll be new line, if not char and herbs char equals an array, and then it'll be herbs char array push. Great, and we have our graph. We love our graph, big fan of graph. We have distances from the start to where I want to go. And this is where we go through it and we find the first one we want to go to. So it's kind of, if I were to make, we don't want to do that. We kind of want a const q, and that's just going to be object.keys herbs. We got to get all these herbs, right? And then it's while q.length const next equals q.sort a b. And it's basically the next closest one. So let me try and figure that one out. We'll also need a current position lock, which is start initially. So from start to here, so const distances equals Dijkstra graph lock R plus lock C. Yep, go from wherever I am to wherever you want me to. Okay, and then I want to find closest A equals A dot find. Nope. So Q, you're supposed to be an array of strings, buddy. Okay, it's not Q. Let's just say herb types needed. There we go. Next herb type is, and I guess I gotta go into herbs. So closest A equals herbs A, and that's a reduce. I don't have an initial one. I guess I'll use 0. Distance herb, and yeah, we'll start off at 0. So let's say return distance less, well, math.min distance, and then distance is herb R plus herb C. So closest A, and then we need closest B. Again, it feels like a naive approach to this, but it's what I'm thinking of. Let's return closest A. Oh. Minus B. So this is ascending from smallest to largest. I want the smallest one. Next herb type, a 0. So that gives me the next herb type, and then I need the actual herb. Const next herb, which is herbs. Next herb type. Kind of like this, but we're sorting based on it. Sort A, B. So it's gonna be distances. Nope. Distances A.R plus A.C minus, same thing for a B. And then, yep, you're gonna find one. I'll take the 0th one. I will go to the next herb. I guess I'll say path equals empty. So it'll be from wherever I am to wherever I am. So I guess path will be position and distance traveled. I don't know. I need to keep that distance because I'm getting rid of it every time. So, path dot push lock next herb, and what will it be? Okay, I guess my path I can say lock start traveled 0. So I'll push the next path, which will be traveled. I guess I can just leave this here, right? So that is distances, next herb R plus next herb C. And I'll just sum up all the things later. Yeah, that seems right. Now if I'm going to the right ones, who knows, right? So while these are lengths, we're going after them, we're picking one. Yeah, we also need to splice that one out. So herb types needed, splice, herb types needed, index of, next herb type, and get rid of 1. There we go. So yeah, for this naive approach, this might be it. Hopefully no infinite loops, alright? Boom, no infinite. Man, that's part 1. Glad that's still working. Right, I'm returning this thing. I should probably sum up all the travel distances. Reduce A plus B dot traveled. Start at 0. There we go. So I went to 35. What? Oh, return to the entry point. Oh, oops. Yeah, so once you're empty, you need to go home. Interesting. Herb types needed. So if I just mark home as a herb type, I can cheat with that. What's a special herb type that... I mean, it's alphanumeric, right? I'll make it Z. So let's say world start R start C equals Z. And there we go. Here we go. I can't go to the Z if I'm already there. You know what? Maybe instead of being all fancy, I'll just hard code it. Just literally do another iteration. So yep, you do it, you do all the things, and then your distances from your current location to your, not next herb type, not next herb. I guess your next herb technically is start. You want to go back home. Yeah, I think that's a good call. Now this is where things are going to break down. Oop, do you never go home? That's supposed to take you home. Interesting. Let's look at the path. Okay. I mean, let's look at the locations, I guess. So 0, 10. Let me use my eyes a little to help with this. Okay, so yeah, we start at 0, 10, and then we go to 3, 17. 0, 1, 2, 3. 0, 1, 2, 3. What am I looking at? I'm looking at the wrong one. Dang it. Okay, 0, 1, 2, 3. 17. Right, it takes the wrong A. Dang it. So I kind of think I need different split universes of what happens if you take any of these A's. I can see that literally failing in these ones, though, where you do a bunch of split universes and you just... like, all these are practically the same. Can I literally... Oh, this is literally only part 2 through, yeah. Part 3 is going to make it harder where I won't be able to just cheat. Plus, which one of these you pick might make it easier for you to diagonally into the B. Or... yeah, complicated. But I think the naive approach ain't gonna work like that. But this is the iterative approach, so I think we're just gonna need to have a bunch of paths. Because paths equals an array of objects, where you are, where you're going. For each one, you pick your closest next herb type. Would that be the easiest way? You just have them always target this. So if I'm just saying, hey, find me the closest A, no, that's not going to work. So I have all these herbs available. How do I narrow it? Well, I try all of them and make a path for each of them. So a path going to this one, a path going to that one. And then based on these, it will be a path going to next one, or to next one, or to that 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 one. The great thing is, as soon as we find a valid path, we can start eliminating the longer ones. But and this will be depth first, so that will happen quickly. So I think what we do is we start here and we determine our next herb type as all 3 are options, and then we pick the closest of the 3. Or do we just pick all of the 3? It has to be all, because we know the closest A is literally the wrong one. Okay. Let's start on this. Whew. Path equals top. Location is not the start. It is... Well, I mean, I guess I can look that out. Lock. Nope. Location and traveled. Does not exist on the array. Alright, so there are arrays. Forgot. So, I guess this will be path at -1, which is where I can pull this out. Okay, so we just need to try everything if possible. So it's not herbs type needed. So yeah, each path is an array of things that objects we've been to. We also need to keep track of herbs needed. So which means each one is an object. Herb types needed. There we go. We can initialize this right here. Okay, a little better. I guess traveled is... Sure, yeah. So we don't need traveled for this particular bit. So we're just going to try them all. And then which one we push forward is the one with the least traveled. So... herb types needed. It's basically going to go through all the herbs, be like, hey, which ones do we have? So const next equals this. So for const herb of herbs, if world, let's keep it on the herb. Why don't we? Oh, there we go. For herb type in herbs. If herb types needed includes doesn't include. And instead of include, let's go for a new set. Not a new weak set, a new strong set. Normal set. So if it doesn't has continue, we don't care about you. Otherwise, it does, we want to consider you. So next dot push all possible herbs. So herbs, herb type, if you ever want, all of y'all. Y'all are possibilities. I'm trying to think. We need from where we are, where we're going, so distances can be up there. Yeah, we're going to push them all, and I think the order in which we push them will make it so the pops come off next. So let's start commenting these bits out, because we need them, but not like that. Just drop the while loop, drop this, and this is technically when I am out of herbs. So, if not next, if not next dot length, push, which is, here we go. Well, let's start. We push a new start, basically. So before we do that, here's what we do. There we go. Now we don't need to have that duplication lying about. Okay. Yeah. Path equals null. It's going to be null until someone reaches the end. Okay, so now we want to sort all the next. Sort A, B. Now it's distance. So kind of like this. A distance. Wait, can I just call this the entire thing? I think I can. There we go. Distances, distances. We're not picking one. So we're going from closest to longest. It's ascending. We want it descending. We want to put the worst in the front of this. So B goes first because we are popping out of this. There we go. Next is like this, and then we just want to push all of them basically. So path, push, path, which is path, next. Well, we want to map over the next, so there we go. And we're missing some stuff. What is this? Herb types needed. Well, I need a new version of it without it. See, I need some multi-line stuff. Herb types needed. That is from herb types needed. Make a new set from that one. New herb types needed. Remove or delete something. Then we have new herb types needed. Our type is still missing something. Argument of path any. Ooh, path location and traveled. So I have location is next. Traveled is distances. Next R. Next C. I think I lost a plus. Feeling better. Any is not assignable to any number. Don't you worry. Distances is okay, it's not giving me the thing. Don't worry about it. Again, we're just fighting TypeScript, but I like this to be accurate. Any number is not assignable to any number array set. Arrays of I have done that. Okay, what is path? Path is an array of these things. I'll make a new path. Not sure what I've done wrong. New path. The heck is a new path? It's an array of things, and boy, you are just angry, aren't you? It just hates everything. Let's just drop this so I can maybe inspect what the heck this is. The path is an array of objects. Looks like to me, path, location, traveled, herb types needed. Oh, there it was. That's all it was missing. Okay, I did all that for nothing, kinda-ish. Okay, we have generated the thing. We need to delete the herb type we're adding. So push herb type. I'm gonna put that in here. I collect my herbs. Row type car. There we go. Delete. And who's the new herb? Next type. There we go. And that will be undefined in one of them because that'll be my start, but that'll be perfectly fine. Okay, and this is where we start hitting it up. Basically, if this happens, we need to be like, hey, you reached the end, buddy. I want to do that or wait for that. Because eventually we're going to pull through and be like, you literally reached the end. There's nothing left for you. And that's going to hit this, which is going to make it keep going back to the start and the start and the start and the start and the start. So I need to catch this the first time it happens. What is final path? False, and then final travel equals true. Here we go. So if is final travel, then you literally just pushed one thing. So I'm gonna be like, hey, that thing you just pushed, give it back or don't push it. Let's say let's extract this a little bit. So const new paths is this. New paths. Want this in the else. No, they're not jumping anywhere. So const final path equals new paths. Whoa, no new paths. Promise rather. Then I want to get that distance, right? So I just want to add up all the traveled. A plus B dot traveled. Start at 0. Total distance. If total distance less than, well, if not shortest path, or total distance less than shortest path. Congratulations, shortest path equals total distance. So that works for that one, and I can return shortest distance, shortest path here. I think that'll work. I don't think it will be optimal, but I think it'll work for the example. No. 36, 38. Well, at some point you said this was the best one, and you took it. So we need to know why. Which means I'm putting a breakpoint here. Let me in, but we're really close. So let's see the ones that we decided to take. Shortest path is new paths 0. Yep. Okay, so let's see the locations we traveled. 612. You went to the B first. You can't go through water, you dummy. I didn't add that to my world, did I? Of course, too. If it's a dot, then you start on it. If it's alphanumeric, you can go through it. If it's a thing, you don't look at it. Or if it's a wiggly water, well, you will look at it in part 3, I bet, but you don't look at it right now. Boom! Okay, so this is either going to work or destroy my computer. I'm going to go for it. And as that eats my computer, I'm going to think of the optimization. So total distance is kind of a thing we want. We don't want to keep recalculating it. So we have a path, we have herb types of mist, we have total traveled 0. We want to add that to the new ones. So let's pull that out from this. Total traveled, which is total traveled plus whatever I'm traveling for the next one, which is new path. I guess it's this bit. Yeah, it's eating my computer alive. Now that we have that, we can just be like, hey, what's your total traveled again? And just use that. Don't have to keep recalculating this. And this will also allow us to say, hey, if these ones are longer than the ones we've seen, don't go down these routes. So if path total travel less than or equal to, because for greater than, then they're already longer than a short one we've seen. So keep the ones that are less than or equal to shortest path. Okay, now I need to reload this because I do hear fan going fast. I should not have let it go on for so long. Are we gonna hit a not responding? Okay, I know we survived. That's good. But before I hit this, great things we can just run it on our example. No, I hit the null. Okay, I went too fancy. Shortest path. Okay, I need to just drop this instead of a thing to be a number max safe integer. There we go. I'm liking it. Am I risking it? I'm risking it. I shouldn't have done that. Okay, let's make a QTS. Yeah, there's obviously an optimization I'm not doing here. Reload the window, save us that time. What's 14 doing here? Don't know, don't care. Think we can ditch this. I know the Dijkstra is expensive. Would there be a way to short circuit it based on, well, I need to try all of them. If I short circuit it, it would run quicker. Oh, I think I need to cache these. Distances from. Yeah, this is a caching opportunity. I'm not going for it yet. Const distances from equals new map. Const from equals here. If from and distances from equals Dijkstra, because we're literally recalculating this unnecessarily. Distances is distances from. It's going to cost us a little bit in memory, but we're going to go faster. I think that's a lot faster. I can't really tell. Either way, I'm not giving it to chance. Let's get part 2 cooking. There we go. Let's trim out the rest of this. I think this will be sufficient. Q. Okay. So it's running. Interesting. So I'm trying to think if I've ordered this correctly to make it reach the end as soon as possible. Okay, so we're going to largest to smallest. Well, B to A. So that way we push them at the end. I mean, I could start logging this. Might help. Oh, that's a number. I'm gonna take it. Boy, part 3 is gonna be so tough if I get this. Just do it more. Okay, okay. Okay. I'm a little unconfident by the fact it took like 30 seconds for my thing to run. What's the worst that could happen? You know, it doesn't... Oh, it is a little bit bigger. JKQR. It was being weird about being like, hey, familiarity. Oh, it's literally tripled me. Dang. Wait a minute. Familiarity means if I've been able to use the same path, I should be able to just do it in triplicate almost. Okay, let's let it run. But I see what they're hinting at. Because I found the optimal path. Wait, how familiar are we? Okay, we're not that familiar, unfortunately. There are some kind of differences. Hold on, let me look. Yeah, it's not the exact same thing, unfortunately. So yeah, that's gonna run for a minute. I might not get part 3, honestly, because I don't have the correct algorithm in place. Definitely not gonna get it optimally. Okay, let me look. Just look on it, I guess. Now that we know that I do have the right code, so I might as well put that in the thing here. I don't have an example, so I'll bring this down here for what we're gonna be doing. Still going, okay. So what I really need to do, so I can do some checks to make sure I'm doing this in the right order. Which would be basically just checking this breakpoint here, I think. You know what? I think I can do it on 2. There's enough information here for me. Okay, so we have all our current path. Where's all the paths? Yeah, I have the next one. So the next is basically, hey, try literally any of them from this position. Right? That's what I need to do. So then the thing is, then hey, we have gone to all of them from this position. Now, I was about to be like, hey, we don't need to go to all of them. We only need to go to the closest one. Wrong. Closest one is not the most optimal one, so we need to go to all of them. We are starting with the C's, going to the B's. Okay, this order seems wrong. This was sorted and everything. I mean, yeah, we have new paths. That's all great and all. Do they all have all their stuff? Yeah, A, B, A, B. Eventually I'll see A, C. Sure, yeah. That's great and all. We'll be pushing the smallest one, which is taking me to a B? Hold on, I'm confused. So we're pushing the new paths, which 612 says B. Okay, so 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one is closer than that. Either of the A's should have total travel. So it's 10. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 10, sure. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14. Okay, I don't blame you. It's the closer one. Okay, sure. So that's gonna happen. So we're going down the wrong route for a long time, at least on this one. Yeah, we have 4 next. So yeah, you can go to. I see. There's a lot of wrong. But we are constantly going for the one with the least amount of traversal. Right. I'll put these in here actually. Yeah, now we're looking to the 2 C's, which there are only 2 C's? Oh, there are only 2 C's. Yeah, you should go to the closer one, obviously. And then we're gonna be like, hey, look, we found one. Then the next time this goes through, a lot of these paths are gonna be quieted up because this is the next shortest one. Gonna go through all our paths. Ooh, we're not getting rid of the old paths when we do this. We need to get rid of the old paths when we do this. So after you do this, we need to do a clean sweep. We don't need to do all that extra generation. Boop, boop. Paths equal paths.filter. Path total travel less than or equal to the new shortest path. That's gonna make things a little quicker. Okay, it's freaking constant. Let's fix that. Okay, a little better. That thing is still eating my computer. No, path is not defined. Wonder why. Okay, I think that's a lot more efficient. Thing's gonna run. What I can do is I can drop that. Yeah, just so I can see the timing on this. I don't have that. I can do some logging. I need the front there. Boom, boom. I thought that thing finished. I heard the fan go down a little bit. Okay, so yeah, we're just going raw. I think this was like a 30-second thing. Let's let that go. Then I'm gonna bring the new one here, which honestly it just adds this filter, but could be the thing that does it. I know this one's kind of eating up cycles, but it shouldn't be that bad. I'm trying to think if I can do any memory free ups. Oh. Oh, okay. I was about to be like, where'd that number? It means 40 seconds. Okay, so now if we do this, it should be less than 40 seconds. Hopefully by some actual good margin. I'm trying to think of what I could trim next. Back what I was saying, I could do all these distances by from. Basically, as soon as that thing is no longer a thing being considered, I can clear these out quicker. And I'm just building and building and building memory, which is better than recalculating it every time, but still. So it's basically just need to keep a counter of distances from and be like, hey, I'm looking at you. Wow, 6 whole milliseconds. So impressed. Okay, it might be. Let me see. Dijkstra multiple shortest path. This is. Yeah. Use the wrong algorithm. Yeah, I think I will take a break and circle back to this. Because I'm always applying the wrong algorithm to this. Like I kind of anticipated, this naive, efficient brute isn't going to give us good results. It'll probably complete though, but not good results. So, I will be back when it finishes, or I think of something better.